Lesson 6, the efficiency equation. As a kid, I hated this. It just confused me. I'd like to think I'll do a better job than my teacher did, but here we go. Efficiency means how much of the energy you put in, goes through the machine, which does all sorts of wonderful things with their cogs and the lights coming off and the sound and it moving, whatever it does, whatever the reason is you built that machine, how much comes out that's useful? Because what comes out that isn't useful is going to be wasted. And there is no machine ever that will ever have 100% useful energy. No machine, if you put in 50 joules of energy, will create 50 joules of useful energy. It just cannot be done. It's one of the fundamental laws of our universe. So let's give you a nice example. A few years back, the EU said, everybody stop selling filament light bulbs. They're really bad for the environment. And the usual knuckle draggers went, oh, you can't tell us what we could do with our light bulbs. But you're killing the planet. Well, it's our choice. So here's why they got rid of them. Take an old-fashioned filament light bulb. I think you can still buy specialist ones, but the general ones, pretty much gone now. It's all LED and LED and I can't remember the name, compact filament something. Anyhow, let's put in 100 joules of energy. It would be electrical, because that's what goes into a circuit. Electrical. And it's going to do its job, which is being a light bulb, so it's going to turn it into light. But it's also going to do something very naughty. It's going to create a heck of a lot of heat energy. So we're going to draw it like this. And we're going to say light. I'm going to highlight it in green. Green for good. It's why you built a light bulb. And then we're going to get loads of heat. Heat, I'm going to put in red. Red for bad. It's why you didn't build a light bulb there. You know, you get it, you don't want it. And the typical numbers genuinely were about 5 joules would come out as light, so the remaining 95 joules would be heat. And from that, we can calculate the efficiency. The equation for it, efficiency, we can write it in percent, or we can write it as a decimal, 0.00. So we can write it either way. I'll write it for percent first, is useful energy divided by total energy. Both in joules, obviously. And if I want to turn this number into a percentage, I just times it by 100. That gets it into percent. I'm going to colour code them. Total was the total going in. It's neither good nor bad, so I'm going to go pink. Useful, though, was the reason you built it. Green for good. So we can see here that this light bulb had 5 joules of useful over 100 joules of total energy going in. Times it by 100, and by look, they cancel out. We have here an efficiency of 5%. So 5% of all the energy we were generating to light the country was going towards light. The other 95 was being wasted as heat. For every pound you were spending to light a light bulb, 5p's worth of light was made. 95p was being wasted just to heat up the air. So you can see why eventually they knocked it on the head. And now current light bulbs are around 20, 30, even 40% efficient. So that's huge savings in the amount of CO2 we produce, the amount of money we spend. The heating is negligible, even on a big light bulb. It'll heat a small room up maybe a little bit. So it's not really about the heat heating us up, but it's about the money we're not wasting and the pollution we're not creating. Now, it doesn't look like it, but yeah, it goes in an triangle. So let's give it a go. See if we can make it fit. This time we're going to do it as a decimal. So we can put efficiency here, EFF, useful at the top, and total at the bottom. And we've just got to remember that this one will give us decimal answers. I'm not even going to try and squeeze that 100 in. You can fix that afterwards if you need to. So, for example, if we had a machine that had an efficiency of 20% and the useful that went in was 15 joules, and the question was what's the amount of total that you put in, then we can use this triangle. So let's put it in. So we'll do a triangle. I've given up trying to do it computerized. I'll just draw it scruffy. Let's get the efficiency in. Well, the first thing we've got to do is convert that into decimal, like that, 0.2. Total goes at the top, 15. And the answer is, well, if we did 0.1, 15 divided by 0.1 is 150, but it's 0.2. So I think the answer is 75. Let's give it a look. What was it? 15 divided by 0.2 equals 75. There we go. Lovely. So we can say the total energy that went in was 75 joules going in. So that's the efficiency equation. The only time you might see it different is if I take a copy of this a minute. There's one modification to it, and it's not a biggie. If I paste that there, you might see it in terms of what we learnt last lesson, and that is not energy, but let me get rid of that and that. It's in power. So they might say, what about the useful power and the total power? Exactly the same thing. Just plug the number in, get the answer. So don't freak out if you see it written as energy or power. It's exactly the same equation. You just put the number in. It makes no difference whatsoever. So, as always, photograph of your notes. Google Doc or photograph, attach it, press hand in. Makes a nice easy list for me to keep an eye on you. If you're struggling, give me a call and hopefully I can help you out. And that's it. Good luck. Bye.